Hello, this is Jiajun Wang. I am going to discuss my whole paper by the PowerPoint I created. So the title of my paper is the TLB size matters. The whole paper is discussing how to invest the impact on the visual memory performance. I think we can dig this into more detailed parts by defining the related research, and I have some motivating examples, and also I done a experiment by the hypothesis I made, and I have some evidence to support my hypothesis, and at the very end I have my inclusion and the future work. So we can start with our problem. I am focusing more on the memory management vs the page size. Basically, it's about when we increase the page size, what would be changed in our memory management. And in next slide, I would relate this into a real-world example. So what brings in my mind about the motivating examples? Like in the modern society, we have a lot of real-world examples for the memory management problems. So what I noticed is that the web servers, so this one is to handle the dynamic content, which would include experience in the page size affecting the speed of data, and it would finally deliver it to the user. So I think this is this is more related to our life experience, since we are the user side. But basically we only care about the user side. We do not dig in behind of the web. So in my example, I would say it serves diverse data types and would result in the unpredictable memory access pattern. And the reason why I care about this is because the speed at which a web server retrieves and delivers content would relate users' experience, as I said before. That's why we are going to dig more detailed in our experiments, and finally we can make a trade-off and hopefully optimize the opportunities. So with our informations we got from the web servers, I started from the hypothesis. I made 3 of them. The first one is that if we have a larger page size, maybe the TLB miss rate will be smaller. We don't know. Okay, so if we have a smaller page size, is there any better performance on the system? So the last one is that if we have a larger page size, will the memory intensive application efficiency increase or decrease? Maybe it's application based. These are all about the TLB size influence. So the performance of the virtual memory system is sensitive to the TLB size, as we know. And maybe increasing the TLB size will contribute to a reduction in the memory management overhead. It will potentially improving overall system performance. At this point, you might be curious, how could you get those hypotheses? Which academic paper would support your hypothesis? Yes, I have done several related research. So the reference, all of the reference, I have read 3 of the paper. They make me consider the lightweight memory management in the visualized environment by exploring the trade-offs in the different weight of the workload. As in my example, I picked up 2 workload in the same baseline, and then found it that is crucial and get a slight of the impact on the performance. Also, for the dynamic page size management in visualized software this would also examine the challenges and benefits of the dynamically adjusting page sizes in the Visualize software, and the impact of the TLB handling are discussed in the second one. So this suggests that the TLB handling in different implementations and using the experiment to see like the variations and suggest the choice of the page table. In our case, that's the page size. And the paper also mentioned about the MMU, but I did not focus more on the MMU since I am using a Mac OS system. So I have a default 4KB baseline. What I am more impressed by this paper is it said with the minimal interrupt dependencies, are there any software management TLBs and other software managed the schemes would in fact overhead. So the last one is more focused on the TLB miss importance about the overhead. It said it's caused by like the big memory workload. That's what I said before, since if we have a large page size and then we have small miss rates, this is not like our garbage collection during the coding part. The points are also mentioned in the third reference academic paper. That's the why is provide a trade-off with different memory management strategies in the real-world applications. So with all three papers in my mind, I can start my own experiment. So my experiment is about TLB size and page interaction. It explores the interaction between TLB size and page size and their combined impact on the system performance. So what I would do is following the following step. First one, I would select a baseline TLB size and a baseline page size. At this point, it's 4KB by default. And the second step is to execute the workload and measure the performance matrices. And the third one is systematically vary both TLB size and page size to create a matrix of the combinations. And then I can analyze from the combined effects of the TLB size and the page size on the TLB efficiency, memory management overhead, and overall system performance. So my goal is to identify the optimal combinations of the TLB size and a page size for enhanced virtual memory system performance. So I think I would relate this with my hypothesis, but as I said, the experiment might support my hypothesis and it might beat the hypothesis. So in my situation, I got a table with all the data I have. I record the CPU time, faults, page ints, real memory size, virtual memory size, shared memory size, and the private memory size. After the experiments and all the detailed data I got, I found that a larger TLB size would reduce the TLB misses and improve the translation efficiency, but this would result in increased hardware complexity and possible higher TLB access latencies. This is important since it would impact the overall system architecture. So we can say with a smaller TLB size, we have a more TLB misses and get more page table walks. When we have a smaller page sizes, fine-grained memory utilization would be more, and it will increase the translation overhead. I found assess how well the chosen TLB and the page size configuration scale while increasing the system demand, user load, or size of the virtualized environment. So for the future work, I would say reading more academic papers to extending the direct segment approach in diverse environment and workload. This would explore more potential optimization, which would help our user experiments. And I have listed all the reference I used. Alright, that would be all of my presentation. Thanks for your time. Have a great day.